Hi, welcome to question 6 of the 2023 paper 2 for the Leaving Cert Ordinary Level. As always, if you want a copy of the notes I'm working off, just send me an email at shanetroy@gmail.com. Like and subscribe to get access to more playlists. So question 6 is generally the question on kind of constructions, maybe scale factors, not necessarily a theorem, but there could be, a proof of a theorem. So it can be a challenging enough question, but also one that can have the potential to give good marks. So the first part here, part A, is a 15D scale. So if we can get off the ground and get the 5, I have the marking scheme open here on the side. So we to get the low partial is work of merit or one correct element of this construction. So let's read through it. The diagram below shows the parallelogram ABCD. So let's have a look. ABCD. And I see here they have a side of 130. Now, if you know your parallelograms, straight away I go, well, that's 130 as well. Okay. Now, if they're 260, these are 50, aren't they? 50 and 50. So opposite angles in a parallelogram must be equal. So I've got work of merit there. So now it is a construction. So it says then the length of side AB is 8, that's mentioned. The length of BC is 6, that's mentioned. And then the angle ABC is equal to 130. Now it says then construct the parallelogram ABCD in the space below. The point A is given as is part of the line AB. Okay, so they give the point A here and they give it just a line of indeterminate length. Now, I know this is 8 centimeters long, so using my ruler, I'm going to make a mark. Now, I'm going to pretend this is 8 centimeters, okay? And that's the point B. Now, that's definitely a work of merit, okay? Very easy when you think about it. Now, if we can get 2 elements correct, we're going to get up to the mid partial, the 8 marks. Now, I know that this side here is of length 6. I could use the protractor to work out 130 first, and then draw a line and measure 6 centimeters. But the compass is great. Okay, if you set it to 6 centimeters and draw an arc, all of that, now that's supposed to be an arc, all of those points are 6 centimeters away from this center point. So that's where you put the point of the compass. Now I can use my protractor and measure the 130. So let's pretend I've done that. Okay, and maybe that's it. So where they touch is 6 centimeters long, but it's created an angle of 130. Now I'm going to do the same thing over here. Okay, make that, and then you could measure 130, and you're going to make another line here. And then my diagram's going to be bad. I'm going to draw. Okay, my diagram's terrible. Now, obviously, I'll be using a ruler and my protractor. So having your mat set, just in case a question like this comes up, they can be lovely. This is, I'd argue, not the hardest thing in the world. I was messing around with GIFs, so I decided to make one, and I'm not sure if this is any good. I don't remember. So draw the arc 6 centimeters from, then using my protractor, measure an angle of 130, okay, and draw a line from B to C. Then I think I do the same thing over on the far side. Okay, measure an arc 6 centimeters from A, measure an angle of 130, draw that line, that's A to D, and then connect D and C together. And we have our parallelogram. Okay, actually that worked out pretty well. Now part B, okay, is only 5 marks. It looks a bit more challenging in a way because it has algebra, but we may know from the previous part and drawing it that if this side here is 100, well then this here is equal to 100. So once we realize that, I can make the statement 2x minus 30 is equal to 100. So it's just a feature of parallelograms that the angles opposite each other are equal in size. That's what a parallelogram is. Okay. Now, if I was to solve this, this is the equation of one unknown. So I could add 30 here to get rid of the 30 on the left-hand side. Now, if I do something to one side, I have to do the same thing to the far side. I'm left with the 2x. Nothing changes that. Now, minus 30 plus 30 is 0. So they're gone. And 100 plus 30 is 130. Now, you might guess this. 2 times some number equals 130. The number has to be 65. Okay. Or maybe use my algebra. If I want to get rid of something in front of an x, I can divide it by the number. If I do that to one side, I have to do it to the other. Now on this side, the 2 divided by 2 will always divide or simplify to give 1. On the right hand side, 130 divided by 2 is 65. So I know that this is 65 degrees. Now if this is 65, well then this is 65. So straight away on the diagram I have information. So let's read through it, make sure I'm not doing something stupid. The diagram below shows another parallelogram. The size of 3 of the angles are given where x and y are elements of R. So that just means x and y can be any number. Could be a fraction, could be a whole number, could be negative, could be positive. No, it couldn't be negative, could it? Well, maybe it could. And like that's cool. You can basically ignore that. Okay. Now it says use the diagram in the information in the diagram to work out the value of x and the value of y. So we've already worked out the value of x, but just for the notes and to make it prettier, I've shown that calculation here now in a more basic version. And then on the other side here, so if we know that the x value is 65, we calculated that, okay? What am I doing here? Why did I say 65 back here? I was being stupid. Okay. We're looking here for the y value. So the x value there, we worked out to be 65, okay? Plus the 3y is equal to 80. So now we had 2 unknowns here, but we had learned a bit of information, so I can substitute them out, and now it's an equation of 1 unknown, the y. Now I've simplified this, I don't know why I didn't do it out. If I bring this, I take away the 65 here, okay, and do it to the other side, I'll end up with 3y is equal to 15. Now 3 times some number equals 15, the number is equal to 5. That's probably why I didn't do it. And I've calculated x and y. Okay, so I'm just checking the marking scheme, see if there's anything special about it. Nope, okay. I have a thing in there about the assumptions of a parallelogram, and we should have awareness of the shapes, although I gotta say it's not my strongest suit. Now part C here is a 10 marker, and I was looking at the marking scheme just as we were talking, and if you get the correct box ticked, you'll get the low partial, so 4 marks. Now if you're ever stuck, you can go with a 50-50, okay? So like I'm going to pick true because, I don't know, it seems like a square is a parallelogram, okay? And if you know what parallelograms are, you'll come up with a reason like this. So a parallelogram is defined as a quadrilateral, okay? And there's many types of things that are quadrilateral. A square is a quadrilateral, a parallelogram, in which a rectangle, in which both pairs of opposite sides are parallel and equal. Now, a square has all the same properties of a parallelogram, and therefore every square is a parallelogram. So if the definition is that the angles, so this is supposed to be a square, does this angle equal this angle? Well, yeah, they're both 90 degrees, okay? Now, does this angle equal this angle? Yeah, they're both 90 degrees. So therefore they are a parallelogram, okay? Or sorry, quadrilateral, okay? That's it, okay? So that's the end of question 6. If you want a copy of these notes, just send me an email at shanetroy@gmail.com and like and subscribe to get access to more playlists.